I did mention that the smaller stars live a longer lifetime actually than the larger stars. So let's just put some numbers on them here. For example, a one solar mass star, that's what this M with the little circle with the dot in the middle means. That's our symbol for solar mass. One solar mass star with one solar luminosity, that's us, our sun, lives on the main sequence for about 10 billion years. A two solar mass star with 20 solar luminosities lives for 1 billion years on the main sequence. And a 30 solar mass star with 10 to the 5 solar luminosities only lives for 3 million years. The short lifetime of massive main sequence stars implies that those blue, large O and B type stars have formed recently and will still be associated with their birthing cloud. So they haven't moved position within the region where they were formed. Now, one thing to think about when we're thinking about, you know, what can you form around these stars? We know how our solar system planets were formed and the material that was surrounding our original proto-sun. But let's think about that. A similar thing can happen in all of these stars. You can have a disk of material surrounding those stars. You could have planetesimals that bump into each other to create planets. But think about the lifetime of those stars. Think about how long our planet has been here. We know that our sun and our solar system was formed about 4.5 to 5 billion years ago, okay? So it took us that long to get to right now, okay? The most massive stars are done after 3 million years. Even twice solar mass stars are done after 1 billion years. That doesn't give you a lot of time, even if planets are formed or being formed. It doesn't give you a lot of time to let life develop on those planets. So whenever we think about where would we look for habitable zones, yeah, maybe the O, B, A type stars have habitable zones. Even the F type stars have habitable zones around them. But those stars are going to live much shorter lifetimes and maybe wouldn't be even in their main sequence phase or live their lives for a long enough time in order for any life around the planets that are orbiting them to develop anyway before that star ends its lifetime. So when we're looking for habitable worlds, the best place to look is around stars that are about the sun's mass and smaller, because we know that they have much, 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 much longer lives than these big stars. Now, we already mentioned a little bit about what happens when a sun or a star leaves the main sequence. So we're going to talk a little bit more about it here again. Okay, so when a main sequence star exhausts its fuel, the core drops its pressure and is compressed by gravity and heats up, okay? So here we've got a star. It's used up all the hydrogen, and all its hydrogen has been fused into helium in its core. That core begins to contract, okay? As the core contracts, it also heats up. And then the shell of material surrounding the core then begins to fuse hydrogen into helium. And that heat drives the atmosphere of the star outward and it puffs up the star. And that's what's creating your giant phase of the star after it's finished fusing all the hydrogen into helium in its core. And then the core reaches a hot enough temperature that it can start fusing helium into things higher along on the periodic table. Now, the most massive stars don't stop with helium fusion. We know after small stars like our sun have finished fusing all the helium into carbon in their core, then they go out in their lifetimes as planetary nebula and white dwarfs. But those more massive stars, they don't stop with helium fusion. A variety of nuclear reactions create what we call heavier elements further along on the periodic table. The formation of heavy elements by nuclear burning processes is what we call nucleosynthesis. And it's proposed that all elements in the universe heavier than helium were created by massive stars. So yeah, we are all made of star stuff. Pretty much everything surrounding us other than hydrogen was created in the interior of a star. Okay, so we talked about how the largest stars have the shortest lifetimes, just a couple of billion years, okay? But when those stars die, they've fused a lot of material into other material in their core, and then they expel that material into space, okay? That's the first generation of stars in our universe. But then the next generation of stars that are born are able to use that material that's already there, created by other massive stars that have ended their lifetimes. They recycle that material. They're using that material again in order to create themselves and to create new planets, you know, that might be orbiting around those stars. And so over time, you have these massive stars that are ending their lifetimes. Their material goes back into the universe. They've created heavier elements that then populate the universe. And then those heavier elements are then reused again to form new stars, new planets, the stuff that we're made up of, okay? So from death comes life in our universe. All of that material gets recycled again. All hydrogen and helium atoms were created during the Big Bang. That's the formation of our universe. We'll learn more about that later. Other elements, the next elements along the periodic table, lithium, beryllium, and boron atoms, are largely produced from cosmic ray interactions with other materials. Okay, what are cosmic rays? Cosmic rays are high energy particles that travel through our galaxy at close to the speed of light. And they consist of atomic nuclei, which just means atoms that have been stripped of their electrons and they're just left with the nucleus in the middle. And when cosmic rays strike matter, they can create lithium, beryllium, and boron. And then the other elements on our periodic table beyond those are either made in stellar interiors during the death of massive stars, or are human-made in a lab, and those are only the heaviest of the heavy elements. Here is our periodic table for nucleosynthesis. The last time you saw a periodic table might have been a long time ago, okay? So here it is, and these elements, the letter here is the abbreviation for the element. These elements are arranged according to their atomic number. That's the number of protons in their nucleus. So hydrogen up here has 1 proton in its nucleus. And then we have, behind my picture here, we've got helium that has 2 protons, lithium has 3, beryllium has 4, boron has 5, carbon has 6, nitrogen has 7, oxygen has 8, iron has 9, and so on, okay? And then the colors here correspond to the process that created these elements. So we've got hydrogen and helium formed in the Big Bang. Lithium, beryllium, boron formed from cosmic rays. And then these other colors, if it's green, those were formed in the interior of large stars through some fusion process, okay? S formed in the interior of small stars during some fusion process. And then the red here with the $sign, those were formed by supernova. And then the purple ones with the M are man-made. So you see that the majority of these elements are formed by supernova or in the interior of stars. Okay, so again, we really are made of star stuff. This material after a star ends its lifetime and expels its outer layers in a supernova or planetary nebula, that material is put back into the universe to be recycled again to create the next generation of stars. And so far, we think we're on the 3rd generation of stars since the beginning of our universe. So the first generation of stars we call population 3 stars. And those stars are what we call stars that have low metallicity. A metallicity in astronomy just means anything really other than hydrogen and helium. So those were the original stars. They hadn't been able to reach the end of their lifetimes to fuse other elements in their interiors to create the other elements on our periodic table. So then after the population 3 stars, we have the population 2 stars, which were the next generation of stars after the original stars. They were able to recycle some of the material from the first stars and were then able to create other elements further along on the periodic table in their interiors. And now we're on what we think is the third generation of stars, which we call population 1. These stars are the more recent stars that have been born in our universe, and they have the highest metallicity. And again, metallicity means that they just have more material in them other than just hydrogen and helium. Really and truly, it's the cycle of life. Things are created, they die, and then new things are born from that leftover material.